Welcome to my channel SP Star Chemistry. Today I am going to discuss you about the next rearrangement, that is the Dienone Phenol Rearrangement. Here the 4,4 di-substituted cyclohexadienone on acid treatment undergoes 1,2 migration to give the phenol is known as the Dienone Phenol Rearrangement. And the driving force for this reaction is the regaining of the aromaticity. Now let's discuss about the mechanism of the Dienone Phenol Rearrangement. Firstly, in acidic condition, the lone pair of oxygen gets protonated and we get this. In the next step, this bond shifts here and this bond shifts here so that it can neutralize the positive charge on the oxygen, and it leads to the formation of carbocation. Now here in the next step, 1,2 migration takes place and we get this. Again in the next step, removal of H plus takes place so that we get the phenol, that is the regaining of the aromaticity takes place. Now in this example, again firstly the protonation takes place and we get this. In the next step, neutralization of this positive charge on the oxygen takes place and we get this. Here the formation of carbocation takes place, but here the question arises, which group migrates preferentially? As in Dienone Phenol Rearrangement, the transition state is a cationic, so that the group which can stabilize the cationic center migrates more rapidly. So here migration of phenyl group takes place and we get this. Again in the next step, regaining of the aromaticity takes place and we get this product. Now in this example, the phenyl group and the CO2 ET group is present, but here again the question arises that which group is to be migrated, either phenyl group or either CO2 ET group. But if we migrate the phenyl group, then we will get the carbocation near to the CO2 ET group. So it will destabilize the carbocation. Hence the phenyl group is not migrated here. Instead the CO2 ET group is migrated. Firstly the protonation takes place and we get this. In the next step, this CO2 group migrates here, this bond shifts here, and neutralization of the positive charge on the oxygen takes place. I am showing this all the reaction simultaneously. And the formation of carbocation takes place near to phenyl group, which will stabilize the carbocation. And in the next step, regaining of aromaticity takes place. This was the same question asked in one of the previous year NET exam. Now, in this example, firstly, we will get this. Here, you may think like that this group, that is the methyl group, migrate on this side to avoid the steric hindrance. But this is not true, because if I migrate this group, this methyl group on this side, it will not stabilize the carbocation with this bromine through the mesomeric effect. But if I migrate this group on this side, I will get the carbocation here. And if I delocalize here, after delocalization, it is found that this bromine stabilizes the positive charge through this mesomeric effect. That is why the migration of this methyl group takes place on this side, and we get the phenolic system here. Now, in this example, firstly, we will get this system, and in the next step, the question arises that this methyl group is migrated either on this side or on this side. But if we migrate this methyl group on this side, here the tertiary butyl group causes the steric hindrance. So it will migrate on this side, and we get the carbocation formation. And again, in the last step, regaining of the aromaticity takes place, and finally we get this product. Now, in this example also, firstly, the lone pair gets protonated and we get this. Now this group is migrated because the carbocation form after migration will be stabilized with the lone pair of this oxygen atom. And after H plus loss, we get the formation of this product. Now in this example, firstly the lone pair of oxygen gets protonated and we get this. In the next step, migration of this group takes place to give the ring contraction, and it will give this. Now this bond gets delocalized and we get this system. Again this bond shifts here and we get carbocation formation here, and in the last step regaining of aromaticity takes place and finally we get this product.